Welcome to video 6D, and we are almost done with this circle stuff and almost done with everything. So congratulations for making it this far. We're going to have two things in our concept box today, and surprise, surprise, more circles. Circles, circles, circles. So our first one is going to be a picture that looks like this, but we are going to make it much more generic. We're going to label these pieces A, let's put A here, B, C, D. And we're going to be talking about the lengths in this section instead of the angle measures. In the last section, 6.6, we said the angle created in here is half of the big arc minus the little arc. But in this section, we're going to be talking about those segment lengths. And they're related in this way. The external piece, which in this case is A, so you can grab that outside piece, times this entire length, which I'm going to do in yellow, which is B plus A or A plus B, is equal to the other exterior length, which is C, times the other entire length, which is C plus D. So that's the relationship you're going to set up. The outside piece times the whole thing is equal to the outside piece times the whole thing. And again, if you prefer words, go ahead and write that, right? Outside times the whole thing has to equal outside times the whole thing. If you prefer that, I mean, the variables are only there to help you out, so if they don't, replace it with words. Our other relationship that we're going to have is when we've got a couple of segments. Let me see if I can find a picture for you and show you what it looks like. Intersecting like this one inside the circle. So let's go do that. And there's a relationship between the lengths created when this chord chops this chord in half, or not in half, but into pieces. There's a relationship between these pieces, and let's call this A, let's call this B, let's call this one C, and this one D, and I'm going to color code them for you so you can see it. We'll leave A blue, make C yellow, green, and purple. All right, what this one says is that A times B, the product of the two pieces on one chord is equal to the product of the two pieces on the other chord. So you just multiply A times B equals C times D. It's as easy as that. So let's go do it. So this is using this first one, that the outside piece, which is 4, times the whole thing, which is going to be x minus 3 plus 4, is equal to the outside piece, which is 5, times the whole thing, which is x minus 6 plus 5. So I'm doing outside times the whole way equals outside times the whole way. I'm going to clean this up. It's going to become x plus 1. I'm going to clean this up. It's going to become x minus 1 because I have a negative 6 combined with a positive 5. So I'm going to have an x minus 1. I'm going to solve this for x plus, hop that one in, 4 is equal to, hop it in, 5x, hop it in, minus 5. I am going to combine like terms, so I'm going to get my x's all on one side. I'm going to choose to remove 4 from both sides. I'm going to get 4 is equal to 1x minus 5. Adding 5 to both sides gives me an x of 9. So x equals 9. That's a funky looking x, right? And I'm done. This next one demonstrates the property that was in the second part of the concept box. It says this piece, 4x plus 2, times the other part, looks more like a 3, let's fix that, times the other piece, which is 8, is equal to this piece, 4x, times the other piece, which is 9. So I have 32x when I distribute, plus 16 when I distribute, is equal to 4x times 9, which is 36x. I'm going to get my variable on one side by subtracting it from both sides. That leaves me with 16 equals 4x's when I do 36 of them minus 32 of them. Dividing both sides by 4 gives me an x of 4. And I'm done with that one. Next up, let's see what we've got next. One more of these, and then section 6.8, sorry. Find the measure of the line segment UW. So I'm going to get this whole segment. In order to get that, I need to get X. In order to get X, I need to chop that blue one into two pieces, chop the red one into two pieces, and set the products equal. So I do the piece of the red times the other piece on the red is equal to piece on the blue times the other piece on the blue. I'm trying to figure out what X is here. I'm going to distribute. I get 28X plus 28 is equal to 24X plus 60, 12 times 5. I'm going to get my variable on one side. I'm going to subtract the 24s because they're smaller and I like to avoid negatives. I get 4X plus 28 has to equal 60. I'm going to subtract 28 from both sides. And 60 minus 28 is 32. There's a lot of algebra in these. And then I divide both sides by 4. And I get a nice X equaling 8. So basically, if you have the concept box filled in and you follow the map, it boils down to some algebra when you're done. Lots of algebra. So next up is the equation of a circle. And I'm going to tell you how you write the equation for a circle. A circle and you'll get more on this in other levels of math, so I'm going to touch on this briefly, but this is touched on quite a bit in Algebra 2. So I'll just give you a little bit of it so it's not totally unfamiliar to you when you move on to your next level, but we won't get into the details or the proofs of it or anything. A circle with center, and we're going to call the center H comma K. And let's go over here and put kind of a dummy problem over here. Let's suppose, oops, I didn't write K, I wrote 2. H comma K. And let's go over here and suppose that I had a circle at 3 comma negative 2, and that this would be considered the H. This would be considered the K. So a circle with center H comma K and a radius of R. Let's suppose I tell you the radius of your circle over here is 6. Has the equation. This is how that's all related in an equation. And if I were teaching this in a full class or in Algebra 2, we'd prove why. I just want you to be comfortable using it. You say x minus h squared plus y minus k, comes from the Pythagorean theorem, equals r squared. So watch over here on this one that I'm just kind of putting. You don't need to write it down, but I would go like this. X, if the x and y are variables, number that will be given to you. X minus h squared plus, right here, y minus k squared. So let's go over here and do that. Y minus k, which is a negative 2, minus a negative becomes a plus, so be careful with that, equals, and it says it equals r squared. So 6 squared, which is 36, and this would be the equation of the circle. Likewise, you can also graph and once you know the center and the radius and all that good stuff. So if I was working backwards from this and I said, hey, here's the equation, what's the center? You'd say, well, what's being subtracted? 3. What's being subtracted? Well, it must have been a negative 2 to make it plus. It's really whatever makes the, what's in the parentheses 0. 3 minus 3 is 0. Negative 2 plus 2 is 0, if that helps you out. So my center's 3, 2, and I'd say, hey, what got squared to equal that? And you'd say 6. And so it's easy. Let's go up here. Let's pluck off our center. What's being subtracted? 1. What's being subtracted must have been a negative 3, or you can think of what makes each chunk 0. That works as well. And then this 4 is equal to r squared, which means r had to have been a 2. And then I can just go graph it. My center, or my circle centered at 1 to the right, 3 down. So there's the center of my circle. It has a radius of 2, so the easiest thing to do for that is go up 2, right 2, down 2, left 2, and do your best to draw the circle. Next one. You won't have one like this. I just asked the geometry teachers if they do this kind in geometry, and they said no. So we're going to change this one, and we're going to make it x squared. So let me know, too, if when you're taking the test, if you see one like that, you come and show me and say, you said we didn't have to do this kind. All right, and let's suppose I make this equal to 1. All right, let's pick off our center. My center is what's being subtracted, and nothing is, so it means it was centered at 0. I'm going to write this nicer. So my center is at 0, comma, what's being subtracted here, 7. My radius is whatever gets squared to equal 1, which is 1. So when I graph it, I go to 0, 7, right here, 0 to the left or right and 7 up. My radius of 1 means that I am going to go up 1, down 1, left, right 1, left 1, and it's going to be this tiny little circle right there, little bullseye. Write the equation of the circle. We're not going to do this one. So now I can go in reverse. Remember, this is the center, which we call h, comma, k, and the radius is 4. And if you go look at the model for it, we do x minus h squared plus y minus, and now I've got a negative 13, so that becomes a plus, equals r squared. 4 squared is 16. And I've just written the equation for this circle. Let's see what's next. I'm thinking it's a stop sign. Nope. So I added this section because it wasn't in anywhere, and I want you to know how to do these. So this is kind of an afterthought about circles. So let's go split this into sector area. And I'm not going to have you practice this. I just want to show you. I might put one example, but just so you have some exposure. Sector area, and let's over here, right, arc length. So we've talked about how on a circle, the area of the whole thing is pi r squared. And I want you to write that right here, pi r squared. That would be if I were to cover the whole circle. But we're going to do, a sector is like a piece of pizza. It's like you're cutting out a piece of that circle. So what I'm going to do is go grab a highlighter and shade that in so you can see it a little better. So when I grab my highlighter here, do my best to color in the lines. All right, so this is a sector. And what I want to do is find the area of that sector. And in order to do that, I have to realize that it's not the whole circle, it's a fraction of the circle. So if you hear me clicking here, I'm trying to get my pen back. I went to the highlighter and it won't give me my pen back. I'm going to wait and see if it'll come back to life here. Got it. It was my fault, not my smartboard's fault. All right, so it's some fraction. This yellow sector area, which we're going to call S, just for sector, is equal to a piece, a fraction of the entire circle. And that fraction is determined by, I'm going to go in here and draw a little red circle. You don't need to do that. It's determined by this little piece right here. This is called a central angle. Whatever that angle measure is, I'm going to call it x degrees. That's the piece of a 360-degree circle that you're chopping out. So right here, go ahead and point at it. This is the angle measure, which remember also equals the measure of the arc. So the x degrees could be out here on the arc's measure as well. So either or. So it's a piece of the entire area. It's a fraction of it. Again, if it was like this and you did this, it would be 1/2 of the entire area, but it's really 1/2 because this is 180 degrees out of the whole circle. But visually you can see it's a half, so that wouldn't be worthy on that problem. Arc length. Why am I drawing a segment when I'm working with circles? I don't know, I'm losing it. All right, so arc length is a little different. For arc length, we're still going to take out a wedge of pizza, but the arc length is just the crust right here. When I talk about arc length, I just want to know how long this is, and it's a length. So just like over here, the sector was a piece of the area, the arc length is a piece of the circumference. So if I went all the way around the circle, that would be 2 pi r. But I don't want to go all the way around the circle. I just want to go part of it. I just want to get this little crust piece over here. And that's some piece of the whole circle. And again, you have to take out a piece of the entire circle. So it's a piece of 2 pi r. Kind of cool, right? Now it says stop and do worksheet 6.7, 6.8, and 6.9. And then you're ready for test 6. And then we have one more short video and you have made it to the end.